Hello students, welcome to Sri Siddheshwar Women's College of Engineering Solapur. Myself Dr. Yogita Gajanan Datar, subject teacher of Engineering Mathematics 1. In the last lecture we have seen the prerequisites for engineering mathematics. Now we are going to start with the actual syllabus of engineering mathematics as per D. Batu Loneri. The topics in this subject are linear algebra, matrices, partial differentiation, applications of partial differentiation, reduction formulae and curve tracing, multiple integrals. So out of these 5 topics, you have seen the matrices, differentiation. Corresponding to differentiation, you have learnt in 12th standard. Here is a concept of partial differentiation, and similarly for applications of partial differentiation, you have learnt different methods to integrate the given function only once. In this topic of multiple integrals, you are going to solve the examples where double and triple integrations are involved. Examination scheme for this subject is, there will be midterm test of 20 marks. Internal assessment will carry 20 marks. In internal assessment, your attendance, your performance in class test 1, class test 2, your performance in tutorials and assignments will be counted, and there will be end semester exam of 60 marks. So, total weightage of 100 marks is allotted for this subject of engineering mathematics 1. Now we will see the first unit, that is linear algebra, matrices. The subtopics of this unit are inverse of a matrix by Gauss-Jordan method, rank of a matrix, normal form of a matrix, consistency of non-homogeneous and homogeneous system of linear equations, eigenvalues and eigenvectors, their properties, and Cayley-Hamilton theorem and its application. Out of these 7 subpoints, there will be surely 4 questions from these 4 subtopics. So from exam point of view, these 4 subtopics are very important. Now, as here we are going to learn the new concepts from the area of matrices. So first we have to revise some of the concepts from this area of matrices which you have learned in 11th and 12th standard. To complete these 7 topics from unit 1, as per university syllabus, 6 hours duration is given, and the weightage of this topic in university exam will be of 12 marks. So for 12 marks, there will be 4 questions and you have to attempt any 3 of them. Each will carry 4 marks. Now let us see the basic concepts required for this unit number 1. Definition of matrix, which you have learnt in 11th and 12th standard. Second, types of matrices. There are different types of matrices, but out of those different types, here we should know square matrix, singular matrix, and unit matrix, or which is also called as identity matrix. So square matrix is a matrix which is having equal number of rows and column. Singular matrix is a square matrix whose determinant is non-zero, and identity matrix is also a square matrix whose diagonal elements are non-zero and the non-diagonal elements are 0. So these are the types of matrices you are going to frequently use in this unit number 1. The next is operations on the matrices. You have applied the operations like addition and subtraction of matrices, multiplication of a matrix by a scalar, multiplication of matrices, and you know the condition very well for the multiplication of matrices. You have understood the concept of transpose of a matrix in 12th standard. Inverse of a square matrix, you have learnt methods to find inverse of the given square matrix, and you know the condition for existence of inverse of a matrix. For this you have applied elementary row and column transformation, and all this knowledge is also required here in this unit number 1 of engineering mathematics 1. Now let us start with the first subtopic, inverse of a matrix by Gauss-Jordan method. So here the procedure of this method is that you have to apply only row transformations, no column transformations are allowed, and you have to reduce the given matrix, the given square matrix, to the identity matrix I of the same order. So here question will be like this: using Gauss-Jordan method, find the inverse of the following matrices. Very few times the question on this subtopic is asked, but this part is very important as far as the knowledge of matrices is concerned. So let us solve one example using this method. So here you are given a square matrix of order 3 and you are asked to find inverse of this matrix by Gauss-Jordan method. Remember, you are going to apply only the row transformations and you are going to reduce this matrix to the identity matrix I of order 3. So you are going to reduce this matrix to the matrix, identity matrix of order 3, that is the matrix containing the elements 1 0 0, 0 1 0 and 0 0 1. So let us see the solution, the steps in detail. First, consider the given matrix as some matrix A, and we know that the matrices are denoted by the capital letters. So here we are using capital A equal to the given matrix of order 3. Now, first we will write this matrix along with the identity matrix of the same order, that is identity matrix of order 3, and this is called as augmented matrix. This is called as augmented matrix. So this is the very first step of the solution to find inverse of matrix by Gauss-Jordan method. Now our aim is to reduce this matrix to identity matrix by only row transformations, and for this reason we want here the first row first column element as 1, but here we are having first row first column element as 2. So first we will try to make it 1 by some of the row transformations. The first one, by the row transformation R3 minus 2R1, R3 minus 2R1, we are going to change row 3 of this complete matrix. So first and second row will be as it is. The change is only in the third row, and it is also with this operation only. So by this operation we are getting third row first column element as 1. Now if we change first and third row of this latest matrix, then we can get first row first column element as 1. So by interchange of first and third row, we can get here first row first column element as 1. Now using this 1, we have to make second and third row element 0. Already the second row element is 0. Now our aim is to make this 2 0 using row 1 element. So by the row operation R3 minus 2R1, we get 0 here in this third row first column. Remember, whatever the row transformations you are applying to reduce this matrix to identity matrix, the same row transformations at the same time will be applied to this identity matrix. Now with these operations, the A matrix is also changing and the identity matrix is also becoming some elementary matrix. So it is not identity matrix from this second step onward, and at the same time we are reducing the given matrix to identity matrix. So these steps, these hints, these tips should be remembered. Now we are going to make this second row second column, that is the leading diagonal second row element, as 1. So it is possible using the third row second column element 1. So with the row operation R2 minus R3, or just by interchanging also, we can get here second row second column element as 1, or also you may try for R2 minus R3. Okay, here with row interchange I have obtained 1. At the same time the second matrix has also changed with this row operation. Okay, now our aim is to make this element as 0 using this 1. So for this, the row operation required is obviously R3 minus 2R2. So with this operation we have got here 0, and simultaneously the elements are also changed in the matrix after this colon. Next, now we have to make this element as 1. It is already 1 but with negative sign, so you have to just multiply third row elements by minus 1 so that you can get the third row third column element as positive 1. So the operation minus 1 into third row gives us the required third row third column element as 1. Now using this third row third column element 1, we are going to make these two elements as 0. So we have almost done with the reduction of this matrix to the identity matrix. We have obtained the required first two columns. Now we have to just reduce the third matrix with the elements 0, 0, 1, and for that we require the operation R2 minus R3. So it gives us 1, 0, minus 1, no change in first and third column, the third row elements, only the first row which is mentioned in this operation will get changed. So with this row operation we are getting here 0. Now our aim is to make this minus 1 as 0 with this 1. So the same terms are there with opposite sign, so we have to add just first and third row to get the answer. You can perform these two operations at the same time, but for clear understanding I have mentioned these two operations separately. Now here you may observe this matrix is identity matrix of order 3, and at the same time this identity matrix has changed to some another elementary matrix. A matrix changed to identity matrix, and identity matrix has changed to some elementary matrix. So we can write this as IA inverse. So this is the first matrix, here is a I matrix, that is identity matrix, and this second matrix is matrix A inverse. So from this you can easily write the inverse of the given matrix, that is A inverse, which is nothing but the 3 by 3 matrix with first row elements 8, minus 1, minus 3, second row elements minus 5, 1, 2, and third row elements 10, minus 1, minus 4. So if you are very perfect at the applications of elementary row transformations, then you can easily find the inverse of the given matrix using this Gauss-Jordan method. So here in this method, what is the new concept? only to write the given matrix in augmented matrix form using the identity matrix of the same order, and then to reduce this A matrix to the identity matrix, and you have to apply the same row transformations on the identity matrix also, so as to get the inverse of the given matrix. So this method is also very similar to the method of finding inverse of a matrix using row transformations, which you have learned in 12th standard. So with this, I would like to conclude the lecture. Referring this solution, these steps, you can find inverse of any given square matrix which is having determinant value non-zero. So thank you very much for listening patiently. Have a nice day.